Published 0811 EDT, the 25th of September 2017. Updated 838 EDT, the 25th of September 2017. The first colonists on the Moon and Mars could live in underground caves created by volcanic activity. According to new research, the caves known as lava tubes would provide a natural shelter from cosmic radiation and meteorite strikes for astronauts who set up colonies on our nearest celestial neighbors in the future. Experts hope the research will help the European Space Agency to realize its dreams of an initial lunar base in 2030, which could house thousands of colonists by 2050. Scroll down for video. Lava tubes, underground caves created by volcanic activity, could provide protected spaces large enough to house streets or even towns on the Moon and Mars. Astronauts from the European Space Agency explore one such lava tube in Lanzarote in 2016. Lava tubes can form in two ways. Overcrusted tubes form when thinner lava flows fairly close to the surface, developing a hard crust that thickens to create a roof above the moving lava stream. When the eruptions end, the channel created by the lava is drained, leaving a tunnel a few meters beneath the surface. Inflated tubes are complex and deep structures that form when lava is injected into existing fissures between layers of rock or cavities from previous flows. The lava expands and leaves a huge network of connected galleries as it forces its way to the surface. Two separate teams of researchers have been working on ways to exploit these lava tubes. They are found in many volcanic areas on Earth, including Lanzarote, Hawaii, Iceland, North Queensland in Australia, Sicily and the Galapagos Islands. Previous research identified the potential for the underground networks of tubes, which can stretch up to 40 miles (65 kilometers), as habitats for future space dwellers. Researchers from the University of Padova and the University of Bologna carried out the first comparison of lava tube locations here on Earth with those on the Moon and Mars. To do so, they used high-resolution digital terrain models created using data from spacecraft instrumentation. Their model shows the tunnels that are revealed by collapses or meteorite strikes. The tunnels, such as this example in Lanzarote, would provide a natural shelter from cosmic radiation and meteorite strikes for colonists, but a next generation of spacecraft, under development by scientists at the University of Trento, could penetrate the surface using radar to find the location of previously hidden lava tube tunnels. The work done by the Italian team is already being used in the European Space Agency's astronaut training program. They lead a planetary geology training course called Pangaea for the European Space Agency's astronauts and engineers. The Pangaea project has included a field trip and a test campaign in lava tubes in the Canary Island. This familiarizes the astronauts with geological research they could carry out during future missions to the Moon and Mars, as well as to test technical and operational systems. In particular, Pangaea has focused on using laser technologies to characterize the Corona lava tube, an 8-kilometer, 5-mile-long tunnel on Lanzarote. Both teams' findings were presented at the European Planetary Science Congress, held in Riga, Latvia, from September 17 to 22. Dr. Riccardo Pozzobon, from the University of Padova, said the comparison of terrestrial, lunar and Martian examples shows that, as you might expect, gravity has a big effect on the size of lava tubes. On Earth, they can be up to 30 meters 100 feet across. In the lower gravity environment of Mars, we see evidence for lava tubes that are 250 meters 820 feet in width. On the Moon, these tunnels could be a kilometer 0.6 miles or more across and many hundreds of kilometers in length. They are potentially large enough for quite significant human settlements. You could fit most of the historic city center of Riga into a lunar lava tube. These results have important implications for habitability and human exploration of the Moon, but also for the search of extraterrestrial life on Mars. Lava tubes can form in two ways. Overcrusted tubes form when thinner lava flows fairly close to the surface, developing a hard crust that thickens to create a roof above the moving lava stream. When the eruptions end, the channel created by the lava is drained, leaving a tunnel a few meters beneath the surface. Inflated tubes are complex and deep structures that form when lava is injected into existing fissures between layers of rock or cavities from previous flows. The work done by the Italian team is already being used in the European Space Agency's astronaut training program to familiarize them with geological research they could carry out during future missions to the Moon and Mars. The lava expands and leaves a huge network of connected galleries as it forces its way to the surface. Conventional remote sensing instruments cannot detect and characterize the lava tubes, as they cannot acquire measurements beneath the surface. But Leonardo Cara and colleagues at the University of Trento have developed a concept for a radar system specifically designed to detect lava tubes on the Moon from orbit. The radar probes beneath the lunar surface with low-frequency electromagnetic waves and measures the reflected signals. Next-generation orbital spacecraft could use radar to locate these tunnels, created under the surface of these celestial bodies early in their formation. Hidden under the surface of the Moon, experts currently use high-resolution digital terrain models created from data from spacecraft instrumentation. They model tunnels that are revealed by collapses or meteorite strikes. As in this NASA image, this instrument could determine accurately the physical composition, size and shape of the caves and obtain a global map of their location. Dr. Cara said the studies we have developed show that a multi-frequency sounding system is the best option for detecting lava tubes of very different dimensions. The electromagnetic simulations show that lava tubes have unique electromagnetic signatures, which can be detected from orbit irrespective of their orientation to the radar movement direction. Therefore, a mission carrying this instrument would enable a crucial step towards finding safe habitats on the Moon for human colonization. Children will be born on the Moon in a few decades, with whole families joining Europe's lunar colony by 2050, a top space scientist has claimed. Professor Bernard Foing, ambassador of the European Space Agency-driven Moon Village scheme, made the comments at a conference last week. He said that by 2030, there could be an initial lunar settlement of 6 to 10 pioneers, scientists, technicians and engineers, which could grow to 100 by 2040. In 2050, you could have 1,000 and then, naturally, you could envisage to have family joining crews there, he told AFP on Friday, September 22. Speaking at this year's European Planetary Science Congress in Riga, Latvia, Professor Foing explained how humanity's moon colonies could quickly expand. Children will be born on the Moon in a few decades, with whole families joining Europe's lunar colony by 2050, a top space scientist has claimed. Professor Bernard Foing, ambassador of the ESA-driven Moon Village scheme concept art pictured, made the comments this week likened human expansion on the Moon to the growth of the railways, when villages grew around train stations, followed by businesses. Potential Moon resources include basalt, a volcanic rock that could be used as a raw material for 3D printing satellites. These could be deployed from the Moon at a fraction of the cost of a launch from high-gravity Earth. The Moon also houses helium-3, a rare isotope on our planet, that could theoretically be used to generate cleaner, safer nuclear energy for Earth. One of the main targets for Moon colonies is water, locked up in ice on the Moon's poles. Water can be separated into hydrogen and oxygen, two gases which explode when mixed, providing rocket fuel.